You open Zomato, you add some dal makhani to your cart, and bang, 28 minutes. Your delivery time right there on the screen. No human typed that number. No human even checked it. A system produced it in milliseconds. And to do it, that system followed exactly 3 steps. 3 steps. That's the whole episode. Here it is. Data goes in. A model learns from it. And a prediction code comes out. Data, model, prediction. That's the loop. Every AI system you've ever used is just this loop running over and over, getting better every time. We're going to unpack each box, starting with data. Data is just information, but specifically information the machine has seen before, so it can learn from it. Think about Zomato's data. Every order that was ever placed. What restaurant? What dish? How far away? What time of day? Was it raining? What was the traffic like? And how long the delivery actually took? Thousands of rows, millions of them, collected over years. Each row is one past experience. The machine doesn't reason, it doesn't have opinions. It just looks at all those past experiences and tries to find the pattern that explains the catch. The machine is only as good as the data you give it. If your past orders have missing timestamps, wrong distances, or someone accidentally recorded a 3-hour delivery as 3 minutes, the machine learns that wrong pattern, and your predictions are garbage. Garbage in, garbage out. This is why data quality is treated like a religion in ML teams. Before anyone trains a model, weeks, sometimes months, go into cleaning the data. The model is only as smart as the data that raised it. So the data goes in, but what comes out? What is a model? Think of a tailor who starts with a blank suit form, totally generic, fits nobody. A customer walks in, the tailor takes measurements, chest, waist, shoulders, arms, and adjusts the form to fit that exact person. A model is the adjusted suit form. It's not the raw data, the measurements, and it's not the final answer, the finished suit. It's the thing in the middle, shaped by the data, ready to answer questions about inputs it's never seen before. Training is just the fitting process. Training sounds complicated. It's really not. The model starts completely random. It knows nothing. You give it one past delivery, 4.22 kilometers away, 7 pm light traffic. It guesses 45 minutes. The actual answer was 28. That's a 17-minute error. So the model adjusts, tweaks its internal numbers slightly to reduce that error. Then tries the next data point. And the next. 10,000 data points, 100,000. Repeating this cycle, guess, measure error, adjust, over and over. By the end, the model has found a set of numbers inside itself that, on average, produces the least error across all the past data it's seen. That's a trained model. Now the fun part. Brand new order. 6 kilometers away, 8 pm, heavy rain. The model has never seen this exact combination. Doesn't need to. It already learned the pattern from all that past data. You feed it in and out comes 42 minutes. A prediction, not a lookup, not a rule, not someone's gut feeling. A pattern applied to new information. That's what appears on your screen. Back to Zomato, all three at once. Data, millions of past orders, distance, time, weather, restaurant prep speed, rider performance. Model, trained on all of it. Tuned to minimize prediction error. Prediction, 28 minutes on your screen. Before you even finish placing the order. Data, model, prediction. Same loop every time. And it doesn't matter what the AI system is doing. The loop is the loop, just with different stuff inside each box. Let's run it again with a completely different example. UPI fraud detection. 12,000 rupees, new contact, 2 AM, different city than usual. Your bank system gets this. Same loop, completely different domain. Data, years of your past transactions. Amounts, times, locations, who you pay, how often. Plus, fraud cases the bank has seen across millions of users. Model, trained to know what your normal looks like and what fraud looks like. Internally, it's scoring how far this transaction deviates from your usual pattern. Prediction. Fraud probability 94%. Flag it. OTP check goes out. Same 3 steps. Different data, different model, completely different purpose. The loop is universal. Only what's inside each box changes. Zomato, past orders, regression model, a number in minutes. Fraud detection. Transaction history. Classifier, a probability. Image generation. Image text pairs, diffusion model, pixels. Spam filter, labeled emails, text classifier, spam or not spam. Same loop every single time. What makes one AI system different from another isn't some fundamentally different kind of magic. It's just what's inside the 3 boxes. Once you've got this, you've got a question you can ask about any AI system. What's the data? What's the model? What's the prediction? One thing worth flagging. There's a difference between raw data and what the model actually uses. A photo is just millions of pixel values. Feeding raw pixel numbers to a delivery time model doesn't make sense. And even for image recognition, raw pixels alone are a rough way to start. So engineers build a step in between, called feature engineering, where they pull out the meaningful signals. For delivery time, not just distance, but distance through traffic. Not just time, but is it peak hour? For a photo, edges, shapes, textures, the stuff that actually carries meaning. Getting the model working with the right inputs is one of the biggest levers in building AI that actually works. Modern deep learning has gotten very good at extracting features automatically, which is a big part of why it performs. One more thing to get right. A model is not a lookup table. A bad model memorizes the training data, perfect answers on everything it's seen, falls apart the moment you show it something new. That's not learning, that's just remembering. A good model generalizes, extracts the underlying pattern in a way that holds for data it's never seen. The Zomato model has never seen your exact order. It generalizes from similar past orders to give you a reasonable estimate. This tension between memorization and generalization runs through all of machine learning. We'll spend a full episode on it. It's called overfitting, and it's where most ML projects quietly go wrong. Okay, the model makes a prediction. How do you know if it's good? You test it on data it's never seen. You deliberately held some back. And compare. What did the model predict versus what actually happened? 70% accuracy. Is that good? For spam detection, no. You'd want 99%. For predicting stock prices, 55% would be genuinely remarkable. The benchmark depends on the problem. And this evaluation step does something important. It closes the loop. A prediction lets you measure the model, which tells you how to improve it, which feeds back into the next version. The loop doesn't stop at prediction. It keeps going. Every time Zomato delivers an order, they record the actual time. That goes back into the training set. The model gets retrained. Weekly, sometimes daily. Each version a little less wrong than the last. This is why AI systems improve over time. Not because someone's manually fixing them, but because the loop feeds itself. More predictions, more real outcomes, more data, better model, sharper predictions. It's why the systems that have been running longest, Google search, Netflix recommendations, are so good. Not smarter engineers, just years of the loop running, billions of data points feeding back in. Years of data, you've now got the loop, data, model, prediction, and you know how it runs, how it improves, and why the same 3 steps show up everywhere from delivery times to fraud flags. What we haven't touched. Not all models train the same way. There are 3 different modes of training, and which one you pick changes what kinds of problems AI can solve. Subscribe and stay with us.